Okay, so here we're doing problem number 13.1. This is the question, which is there's a block of weighing 150 pounds resting on a surface with a coefficient of friction of 0.4, and it is being pushed from one side and pulled from the other side at these angles, 30 degrees and 45 degrees. Find the acceleration of this block. Now I've gone ahead and set up the free body diagram and the free body diagram. So let me explain how I got this thing. Okay. All right. So basically what we're doing is, if I take this, we're splitting all these forces into horizontal and vertical forces, because then we can add up all the horizontal forces, and equate them to 0. All the vertical forces, equate them to 0. And in that vertical, the ones going up and down, they would subtract, and in the horizontal forces, the ones going right and left, they can subtract, and eventually we'll get our acceleration. Okay. So in this free body diagram, what I've done is 150 pounds acting downwards. Let me go ahead and I'll keep highlighting as we speak. So, okay, 150 pounds acting downwards. So from the floor, there'll be a reaction going up. So it is not just 150 pounds actually. So 150 pounds plus all of these forces, the vertical components of these forces. Okay, the vertical components of these forces, the sum total. So this vertical force, the 150 vertical force, and then the vertical force going up, they will add, subtract, and whatever is the sum of that will be equal to the normal force or the reaction force, whatever you want to call it. You can either call it N or you can say F sub N, right? Either is fine. Now these the 90 pounds and the 60 pound forces, they can be resolved because they're acting at an angle. They should be resolved into horizontal and vertical components. Okay, so let's look at these components. So this is the horizontal component. So this is the horizontal component. Okay, and this is the horizontal component. How did we get these? Very simple. So these forces are acting at 30 degrees to the horizontal. So this becomes 60 cosine of 30. And the vertical component becomes 60 sine of 30. Same way, this force is acting down and to the right. So that its components would be down and to the right. And the angle is given as 45 degrees. If this is 45, this is going to be 45. So the horizontal component is 90 times cosine of 45 degrees. Same way, this would be 90 times 45. So now looking at all the horizontal forces, we have this 60 times cosine 30, 90 times cosine 45, and then we also have the frictional force, right? Let's not forget the frictional force. The body is moving towards the right, so the friction will be acting towards the left. Right? And how much is that friction? It is 0.4 times the reaction. Okay, whatever reaction is left after addition subtraction of the vertical forces, so that much reaction, a fraction 0.4 because the coefficient of kinetic friction is 0.4 times n. Of course, we don't know n yet. We're going to find that. Again, another thing we need to draw is the acceleration. The body is accelerating towards the right. Okay, because this is a first guess, and it's a good guess because see, all the forces are acting towards the right, even though they're at an angle, going down, going up, they're generally towards the right. So the body is accelerating towards the right. So inertial force the body is accelerating towards the right, so inertial force will act towards the left. We need this inertial force because again this also forms the one of the components of the horizontal forces. Okay, maybe I shouldn't have made it that dark. Okay, that's better. So all the horizontal forces I have highlighted in this light pink, right? And all the vertical forces are highlighted in yellow. So let's just go ahead and sum them up and see what we get. Okay, so let's do sigma Fy is equal to 0, all the vertical forces. So anything going down, I'm going to take that as negative. So doesn't matter, it's just a convention. Going up is positive, n is positive, minus 150 going down, negative. We have this going down, so that'll be negative 63.64. We have this going up, so that's plus 30. Anything else? I think that's it. We have covered all of it. Okay. Right, so this is all equal to 0. So let me just do the math. So negative 150 and 63.64 and 30. So I get 183.64. So I get n equals 183.64 pounds. So that is the vertical reaction force. Okay, so now as you can see, as soon as we have n, we have this coefficient, we have the frictional force. Okay, all right, same thing, sigma fx is equal to 0. Let's see, so we have this 63.64 going to the right, so I'll take that as positive, 63.64 going to the right. This is also going to the right, the 59.96, so I'll say plus 59.96. The MA is going towards the left, so that would be minus MA, and the frictional force is also going towards the left, so minus 0.4 times N is equal to 0. So I believe we have covered everything. We have frictional force, we have MA, we have all the horizontal forces from the two loads acting. Okay, let's and then we can now substitute. So 63.64 plus 59.96 minus 0.4 times N, we know the value, 183.64 equals MA. I'm going to put it on that side. Okay, so well, while we're at it, we might as well go ahead and do something else. So we know MA is mass times acceleration. How much is the mass? Mass is the weight divided by g. Okay, and the weight divided by g is nothing but 150 divided by 32.2, right? So A. Okay, so this is pounds, this is feet per second squared. Okay, and all of these are in pounds, so the pounds and these pounds will get cancelled, and you'll get acceleration in feet per second squared. So I'm just drawing an arrow here, so I'm going to do all this arithmetic and put the number here. So 63.64 plus 59.96 minus 0.4 times 183.64. We get 50.14. So let me erase that. 50.14 is equal to this. So acceleration is equal to this 50.14 times 32.2 divided by 150. Is that right? Yes. So you get 10.76 feet per second square. Sorry guys, I made a mistake here. It's not 59.96. This is supposed to be 51.96. 51.96. Same way, 51.96. So that'll change this. I'm going to write the final answer here. So 63.64 plus 51.96 minus 0.4 times 183.64. So that's 42.14. 42.14. So 42.14 times 32.2 divided by 150. That is 9.046. 9.046 feet per second square. Sorry about that mistake. It's 51.96. I wrote 59.96 here by mistake. Okay, but that's the answer. So just a quick recap. What did we do? We took these forces, right? We took these forces which are acting at some oblique angle, okay, and then we found out the x and y components of it, of each of these, and then we drew the free body diagram, of course, and then the critical point here is the body is moving in this direction, A. So the initial forces are acting in the opposite direction. So that's MA, that is the force. That's the important thing, because here we're dealing with forces, Fx, Fy, we're all dealing with forces. So here we come here and write the equation of equilibrium. Sum of all the forces is 0. And the normal force here, the reaction force, that so we take that, we take the weight 150, okay, and then the vertical components of these 90 pounds and 160 pounds, and we get from that we calculate the reaction force. Once we know the reaction force, we know the frictional force, which is 0.4 of the reaction force, and that is helpful for us in our Fx equation, which is adding up all the horizontal forces, right? So so this component in the horizontal direction, this component in the horizontal direction, the MA in the horizontal direction, and the frictional force in the horizontal direction. Once you add all of these up, you get the acceleration. And also one thing is, we're saying MA, mass times acceleration here. So we have to find mass. How do we find mass? It is the weight divided by G. Okay, and the weight of the body is 150 divided by G. This part here is the mass of the, this is the mass of the object. Okay, and then once you divide the net force by the mass, we get acceleration.